The dysregulation of multiple cytokine signaling pathways plays a critical role in the pathophysiology of rheumatoid arthritis. A continuous progression of uncontrolled cytokine-mediated inflammatory cascades results in chronic activation of multiple cell types, including T cells, B cells, monocytes, macrophages, and osteoclasts. These dysregulated signaling pathways contribute to the persistent inflammation, systemic illness, and joint destruction that is characteristic of RA. TNF-alpha is one such pro-inflammatory cytokine, and anti-TNF therapies have greatly improved treatment of the disease. There are other approved biologic RA treatments that target a single cytokine utilizing monoclonal antibodies or soluble protein receptors. These include anti-IL-6 and anti-IL-1 therapies. There are also approved treatments that target surface receptors on B cells or on T cells. However, despite recent advances, RA continues to be a clinical challenge with the development of treatment resistance and tolerability issues for many patients. In addition, parenteral administration and limited access to biologic therapies may pose significant barriers to optimal therapy of RA. New strategies that therapeutically modulate multiple pro-inflammatory cytokine signals by targeting intracellular signaling pathways that injectable biologics do not reach may provide new opportunities for treating RA. In 1988, a family of non-receptor tyrosine kinases, known as Janus kinases, was discovered. Additional work was conducted at the NIH to further characterize the role of these kinases in the regulation of intracellular signaling. The discovery of Janus kinases, or JAKs, was important because these intracellular proteins mediate the effects of many pro-inflammatory cytokines involved in several human diseases, including RA. It was subsequently shown that activation of many cytokine receptors known to be involved in RA promote pro-inflammatory gene expression by signaling through JAK pathways. These include receptors for multiple cytokines. In fact, these cytokines utilize JAK signaling pathways to regulate the inflammatory activity of many cell types involved in RA, including T cells, B cells, and osteoclasts. Additional studies showed that JAK levels are significantly elevated in the inflamed RA synovium, providing further evidence of the importance of JAK-mediated signaling pathways. This suggests a potential novel therapeutic approach to the treatment of RA. Multiple pro-inflammatory cytokines utilize JAK signaling to modify gene expression associated with the chronic inflammation of RA. Cytokines signal cells by binding to specific cell surface receptors. A specific receptor type exists for each cytokine. There is an IL-6 receptor, an IL-15 receptor, and so on. For many cytokines, regardless of the receptor type, binding by the cytokine results in activation of two intracellular Janus kinases attached to the cytoplasmic portion of the receptor. These activated JAKs in turn activate proteins known as signal transducers and activators of transcription, or STATs, which are also associated with the receptor. STATs are also recruited to the activated receptor and transduce signals within cells. In the final step of the pathway, activated STATs regulate gene expression in the nucleus. Depending on the cytokine and the inflammatory cell, receptor activation and cytokine signaling results in a number of cellular events that accelerate inflammation and joint destruction, including increasing secretion of other pro-inflammatory cytokines, increasing osteoclast differentiation, and increasing bone resorption and cartilage matrix degradation. Thus, JAK-related intracellular signaling participates in a feedback loop that accelerates and sustains cytokine-mediated recruitment and activation of T cells and other cells that promote joint inflammation and destruction. Exploring new cytokine signaling pathways important in the pathophysiology of rheumatoid arthritis, such as those involving JAKs, may result in new strategies for treating this challenging disease in the future.